Question number 7, relating to vectors. So we're given the equation of the plane pi1, and the equation is pi1 is such that r dot 3i minus 4j plus 2k equals 5. Now the general form of a plane is r dot n equals a dot n. These are all vectors. So we've got the r, so we know n, the normal to the plane, is 3 minus 4, 2. Okay, so I know the direction of this, doesn't matter which way I go, is 3 I minus 4j plus 2k. It's some multiple of that. Okay, so we're going from point 6 to 12, and I want to go down to the plane perpendicular, because I want the perpendicular distance. I know the direction from the plane is in the direction 3 minus 4, 2, and I've just got to work out what the multiple is, then I can work out the distance. I'll go from top to bottom. I'll go from the point to the plane, but it won't make any difference at all. If I go the other way around, I'll just get lambda as being the negative. So if I go starting from 6, I'm going to go, the x coordinate is 6 plus 3 lambda. The y is going to be starting from 2 and taking 4 lambda. And the z is going to be 12 plus 2 lambda. Okay, so that's in the I, j and k directions. So I've gone from there to there. Now I know the point x, y, z needs to lie on the plane pi1. So another way of writing this, if we place the r with an x, y, z, I end up with pi1 is also 3x, take 4y, plus 2z equals 5. It's an alternative way of writing the same plane. I've got x, y, z, so I'm going to substitute those into there and find lambda. Okay, so if I substitute them in, 3x's, so I get 18 plus 9 lambda, take away 4y, take away 8 plus 16 lambda, plus 2z, plus 24, plus 4 lambda, and that has to equal 5. And I get 29 lambda equals minus 29, and lambda equals minus 1. So clearly if I'd have gone the arrow in the other direction, I'd have got lambdas plus 1. So I've got lambdas minus 1. So now I know what the vector from the point to the plane is. So vector from 6 to 12 to plane, to pi1, is minus 3i plus 4j minus 2k. And I want the distance, so the magnitude of the distance is therefore just going to be Pythagoras in 3 dimensions. So we get 3 squared plus 4 squared plus 2 squared. Notice I ignore the minus because I'm squaring, and then square root, which is root 29. Okay, so that's part A. Part B, let's move the paper up a bit. Part B. Show that that vector is perpendicular to pi2. I've got pi2, okay. So pi2 is such that r is some multiple of 2i plus j plus 5k plus some multiple of I minus j minus 2k. Okay, so what this is saying is if we've got the plane pi2 this time, we've got, this is obviously not to any sort of scale, let's just draw 2 arrows in. This direction here is 2i plus j plus 5k, and this vector here is also in the plane, which is I minus j minus 2k. So both of those vectors lie in the plane, pi 2, and a combination of those two will get you to any point in that plane. So basically I've got to show those two are perpendicular to minus I minus 3j minus k. So all I've got to do is minus 1 minus 3 1. I've just got to make sure it's perpendicular both of these two directions. So 1 minus 1 minus 2, and that equals minus 1 plus 3 plus minus 2, which is 0. So it's perpendicular to that one. Move this up a little bit. And then I've got to do the same for the other one. So again, minus 1 minus 3 1. I'm going to show it's perpendicular to 2 1 5. Get minus 2 minus 3 plus 5 is 0. So therefore, minus I minus 3j plus k is perpendicular to pi 2. So in other words, that is the normal, that is the n. Okay, so that tells me that I could draw a normal on this plane here, similar to the first question, and this will be, this direction will be minus I minus 3j plus k. Okay, now show the angle between the two is that. So all I'm doing is finding the angle between the two normals. Okay, so what I've got, whenever you've got two planes, so we've got, say I'm looking from the side, I've got pi 1 and pi 2. Pi 1 and pi 2. I'm going to draw the two normals on. Well, I'm not going to draw them on, but imagine the two normals. And I'm looking for the angle between those two. Okay. And because these are 90, this angle here is going to be, if I call that theta, say, this is 180 minus theta. Therefore, the acute angle I'm looking for is theta. So if I find the angle between N1, N2 and N1, then I'll find the angle between the two planes. Clearly, between two planes is going to be an acute and obtuse angle. We want the acute angle. Okay, so I've got N1, N1.N2 is the magnitude of N1 times the magnitude of N2 times the cosine of the angle between them. So I've got N1 from earlier, which was given to us, which was 3 minus, go back up again, it's this one here, 3 minus 4, 2. So 3 minus 4, 2. 3 minus 4, 2. The normal on the second one is here, minus 1 minus 3k, minus 1, 3, 1. The magnitude of that first one is 3 squared, 4 squared, 2 squared, square rooted, so we know that's root 29. Magnitude of this one, 1 squared, 3 squared, and 1 squared is root 11 cos theta. So the left hand side, I do that times that, that times that, that times that. Minus 3 plus 12 plus 2 is 11. So 11 equals root 29, root 11 cos theta. Divide both sides by root 29, root 11, and you end up with root 11 over root 29 equals cos theta, and implies theta is, I think it's 52 degrees to the nearest degree, 51.9 something.